Let's talk about metallurgy, and more specifically today we're going to talk about reduction of oxide to metal. So we know first thing in the metallurgy step is the dressing of ore. So after we get the dressed ore, after hand picking and then crushing and grinding, the next step is to concentrate the ore, meaning we are removing the impurities or gangue from that ore. Now, how do we do that? We can either use magnetic separation, fruit flotation, or hydraulic washing. So after that, you get the concentrated ore. Now, the third step is to convert the concentrated ore into oxide form. So either you can do calcination if it is a carbonate ore, or you can do roasting if it is a sulfide ore. So after doing roasting and calcination, you are converting the concentrated ore into oxide form. For moderately reactive metals like copper, one way to reduce and get the metal is by using carbon, or also known as coke or charcoal. So what this carbon does is it quickly picks up oxygen from that copper oxide, and then it escapes in the form of carbon monoxide or carbon dioxide, and what we get is copper. So now in this experiment we see that the lime water is turning milky because the CO2 gas is being escaped. The carbon, the charcoal used with this copper oxide is picking up oxygen from this copper oxide and is escaping in the form of CO2, and you will see through that delivery tube that it is turning the lime water milky. So in a way, this is a test for CO2 gas. So what is left behind after carbon, the charcoal picks up oxygen from that metal oxide CuO and escapes as CO2 is your copper metal in that tissue. So copper oxide has been reduced to copper metal. So what you get is an impure copper metal.